Here's something that might surprise you. When someone says 1 horsepower, most people picture a single horse pulling a load. But that's not actually what 1 horsepower means. And understanding the difference changes how you think about every motor you've ever worked on. A horse can produce far more than 1 horsepower. In a short burst, like a sprint, a healthy draft horse can generate close to 15 horsepower. Sustain that for an hour, and you're looking at somewhere around 8 to 10 horsepower. But push a horse at that level for an entire workday, 10 to 12 hours, and you'll kill it. 1 horsepower isn't the peak of what a horse can do. It's a carefully chosen estimate of what a horse can sustain day after day without breaking down. That distinction between peak output and reliable, sustained work is one of the most important ideas in all of mechanical engineering. Now, where did that number come from, and why did anyone need it in the first place? The year is the late 1700s. James Watt, the Scottish engineer whose name we still use for units of power, is trying to sell his new steam engine to mine owners across Britain. The problem is, these mine owners already have a perfectly functional power source: horses. Draft horses running in circles, turning pumps, lifting coal. They understood exactly what a horse could do in a day. Watt needed to speak their language, so he measured. He watched horses at work, studied how much weight they could move, how fast, and for how long. He landed on a figure. 1 horsepower equals 33,000 foot-pounds of work per minute. In other words, 1 horsepower is the ability to lift 33,000 pounds 1 foot in 1 minute, or equivalently 550 pounds 1 foot per second. It was a sales tool as much as a scientific unit, and it worked. Mine owners could now ask a straightforward question: how many horses does this engine replace? Watt could answer them directly.
Steam engines gave way to internal combustion engines, and the horsepower rating came right along with them. When the automobile industry emerged in the early 1900s, horsepower was already the universal language for measuring engine output. Then came electric motors, and here's where it gets interesting. Electric motors are rated in horsepower too, because when they entered factories and workshops, the workers and engineers already understood what horsepower meant. The unit stuck across every era of mechanical history because it solved the same problem every time. It let you compare the work output of completely different machines. Now, let's get precise about what horsepower is actually measuring, because this is where it gets fundamental. Work in physics has a very specific definition. Work equals force times distance. If you push something with 10 pounds of force for 10 feet, you've done 100 foot-pounds of work. That's it. That's the definition. But work alone doesn't tell you anything about speed. You could do the same amount of work in 1 second or 1 hour. That's where power comes in. Power equals work divided by time. Power is the rate at which work gets done. So horsepower, every single horsepower, is measuring one thing. How much force can move something a certain distance in a certain amount of time? Here's a thought experiment that makes this concrete. A high-performance sports car might produce 1,000 horsepower. A semi-truck, the kind pulling 80,000 pounds down the highway, might only have 500 horsepower. So could that sports car theoretically tow more than the semi? Technically, yes. The engine could. The car itself would be destroyed. The frame, the drivetrain, the wheels, none of it is built for that kind of load. But strip that engine out and put it in an industrial vehicle built to handle the torque, and you'd have a machine that outpulls the semi with power to spare. And that's the fascinating thing about motors. With the right housing, the right gearing, the right drivetrain, the same power output can be adapted to wildly different applications. What matters isn't just how much power you have, it's how you apply it and whether the system can handle it.
Which brings us directly to HVAC and refrigeration. In our industry, we're moving two things.